This is going to be Taming iOS testing at Square. My name is Michael Tauraso, and I work as a senior release engineer at Square. So what do? I provide CI and release automation for all of Square's mobile apps with the help of a couple of folks. I don't write any of the tests. I don't actually know Objective-C or Swift. Never shipped an app to the App Store. And I come from a Linux and a DevOps background, so you're going to see a lot of those sorts of tools being applied in this talk. So what does Square do? Square has a iOS app we've had for a while that processes payments using this little reader here on the right. I guess that's your left. We actually have 4 iOS apps in the App Store now. We have dozens of iOS developers, and we also have several internal apps that are for doing things like telemetry on our old reader and one of our newest readers that this new reader does Apple Pay and EMV transactions. So what's special about iOS? Why is iOS CI interesting? So iOS is a mobile platform, and what that means is that there's less of a you can't deploy it as quickly as you can a web app. You have to wait for everyone to download it at minimum. And with the iOS App Store, it can take anywhere from a couple of days to a couple of weeks to get the app through the review process and available to your customers. You also have to build on OS X, and you have to use Xcode to build your app. And OS X and Xcode are pretty tightly linked, and they release a lot. So just to give you an idea, these are major Xcode feature releases over the last year. We're expecting 7.0 to happen in September. In April there was 6.3. I put the little Yosemite symbol because that's when OS X Yosemite became the earliest version of the operating system that you could use to run OS X. It was the minimum requirement at that point. So we have to do a lot of upgrades on our infrastructure. Mac and Apple is also a very closed ecosystem, both in respect to being closed source. They do have some open source stuff, but it's not as open as Android or Linux or Docker or any of the stuff you may be used to. And the future plans of Apple are the subject of worldwide rumor and speculation. So generally, no one knows exactly what they're going to do until they've already shipped some code and have a piece of hardware in the wild. So we've been changing the iOS infrastructure at Square for about a year now. We've done a complete revamp. A year ago, we had approximately 30-minute build times. We had reasonably long queue times. We had a lot of manual upgrading of virtualized infrastructure. The infrastructure was a little bit cobbled together. There weren't really any scale plans for how we were going to make it bigger or how we were going to serve more developers with it. We had a lot of mysterious build failures. We had a Jenkins instance that had a lot of quirks in the web UI that needed to be worked out, and it was very difficult to manage. People would change stuff. And so there was a lot of developer support and firefighting. That's what we spent a lot of our time on. So how do we make this better? We assume that change is going to happen, because this is a very dynamic ecosystem. Change happens all the time. And we figure out how to know exactly what's changing, control all the variables in the build environment, and then use that to deliver repeatable builds and ultimately keep up with Apple. So I'm going to go through 4 topics today. The first one is how Square uses Jenkins. I'm going to give you a run through of our software process, how we go from a commit to a built artifact or successful, unsuccessful test runs. Then I'm going to talk you through how we configure our OS X slaves to run builds. This has been rather difficult to work out. There's been a lot of experimentation there. Then I'm going to talk to you about code signing on iOS, because this is generally a confusing topic and something that can be automated, but often isn't. And then I'm going to cover some statistical techniques for finding bugs in build systems, which is pretty exciting. So let's get started with how Square uses Jenkins. This is the flow that changes go through. So it starts as a git commit to either a release branch or a pull request. We use Atlassian Stash, which is kind of like GitHub, in that it allows you to have pull request branches, and that's a special object. We actually use a plugin that we wrote called Stashkins, which unfortunately isn't available as open source just yet. It sits inside of Stash, and it sees anytime you run a git push. It looks looks at your code that you're pushing, reads a config file, and then sends some config over to Jenkins. Jenkins then launches this Ruby suite we have called iOS Builder, which is again a soon-to-be open-sourced, hopefully, thing. iOS Builder actually handles all of the setup and everything for an app. So it checks out the app's repository, it installs any CocoaPods that the app needs, it runs Xcode build, it sets up the simulator. So it's sort of the puppet master for the entire process. So let's go into a little more detail on Stashkins. Stashkins uses disabled jobs as a template, so it has a pretty simple job. When it sees a change roll by, because it's just looking at git pushes, it looks at a config file on the branch that you're pushing to, and that tells it what Jenkins job it's going to be cloning. It grabs the config XML from that Jenkins job, it does a really simple substitution based off the config, and then it pushes that config back into Jenkins and optionally launches it. So these Jenkins jobs are actually pretty simple for iOS. They used to be a lot more complicated, but right now all we do is we check out iOS Builder, we run iOS Builder, and then we have a couple other boxes in our Jenkins config for these templated jobs that say help display the logs, the test results, and store artifacts. So we use a couple of different plugins for this. We use the Promoted Builds plugin to give us kind of a second stage on our release builds that allows us to send packaged IPA files to our internal enterprise distribution site. This is so that Square employees and testers can download pre-release copies of the app and test stuff out. We use the warnings parser plugin. Xcodebuild actually outputs, it's capable of outputting a machine-readable log format, which can be parsed and can go into the warnings parser in Xcode. We also have all of our XCTest tests configured to emit JUnit output. So we use the JUnit test results plugin, again, to make that really, really super simple and available in the Jenkins web UI to our developers. And we use the Swarm plugin to connect our slaves, which we'll talk about a little bit later when we get into slave stuff. So the basic idea between iOS Builder is that we want to separate our release code from our app code, and we want to get that out of the Jenkins web UI. So this is following a lot of the stuff you've probably heard about this conference, of things like the Jenkins file and the workflow Groovy that you can use. We just did it when we weren't and didn't use any of those technologies. So it has all the standard things. It lets you tweak things without touching Jenkins. It lets you expose a config file to your developers, so they don't actually need write access to your Jenkins instance. They just edit a config file in their branch, push it, and Jenkins does the right thing for them. And it also means that you can actually do CI and code review on your release code, which is pretty exciting. We have RSpec tests for iOS Builder that help us be able to change it quickly without causing problems. So here's an example config that we expose to developers. We have a JSON-based config language. These first three, project, scheme, and configuration, are essentially required parameters to Xcodebuild, as is destination here. This is a release config that would be used to push our nightly dog food releases to the over-the-air install site. So there's a provisioning profile. This is our enterprise provisioning profile. And then these are a set of parameters that get passed through to the OTA, the over-the-air install site, that let it render the appropriate button. So when you go log on, you find register version 4.21, and you see a build number that actually came from the Jenkins build number. This is an example config we would use in CI. Again, project scheme configuration. Destination is actually assembled from these two parameters. These parameters are telling iOS Builder to start a simulator, because we're actually going to be, in this scheme and configuration, we're actually going to be running a suite of tests, and those tests are going to require the simulator to be set up and clear, and this is the exact parameters we want for that simulator. So I'm going to talk a little bit about calling Xcodebuild because that's an important part of this. Xcodebuild changes a lot under the hood, but it presents a little bit of an odd interface. So these are the big three that you need: project, scheme, configuration. Schemes in the UI actually include a configuration in them, but there's this weirdness with calling from the command line in that there's a project level setting that says, hey, when you run this project from the command line, use just this other configuration, and it overrides the one that's set in the scheme. So if you want to get the same behavior as the developers are getting, you have to have them specify both of these things explicitly to the process. Destination we talked about a little bit. The last command to Xcodebuild is an action, the last argument on the command line. Build, test, and archive are the main ones. Build, of course, builds. Archive does a more specific build where it actually it creates a archive that is appropriate for App Store submission. So it kind of has all the things that you need to encapsulate an App Store submission. And it actually uses slightly different rules. Archive is more pedantic about the header and library search paths. So you'll often have problems with, we had a lot of problems with Xcode projects where they would build just fine and then when you went to archive them, they'd have a problem. Skip install project setting was another source of this. Whoop, let's go back. Skip install is another source of these sorts of problems. We are using Xcodebuild-export archive, which you can read about in the Xcode documentation for IPA files. There are a number of other ways of doing this and another number of open source packages that are out there for doing this. A lot of them call package application. This broke recently twice, once when Apple released Swift and once when Apple released the Apple Watch. And using this has helped keep our build process stable, even as Apple changes the underlying way that it's doing signing, as they introduce dynamic libs, Swift, and new hardware. This is a flag reference I put together with some of the other flags that we found super useful to use in CI. That includes things like the machine-readable logs I was talking about earlier. We use a couple of sort of companion programs for dealing with Xcodebuild. One of them is iOS Builder. We pipe all of the Xcodebuild's console output through XCPretty, which for successful steps narrows the log down to just a single line, and then when it shows a failure step, it shows you in its full detail and glory. We've also considered using each of these, man, I gotta stop doing that. We've also considered each of these other front ends. Facebook outputs XCTool, which I know works well for a lot of people. We're considering using Fastlane Tools Gym, which has a fairly loose coupling with Xcodebuild, and makes me feel a little bit more comfortable about it. But those are two things to check out if you're setting up one of these systems and you want to run Xcodebuild in a clean way. So that's it for how we use Jenkins. I'm going to talk now about how we configure our OS X machines for builds. So when we started out, we had virtualized infrastructure. Virtualizing OS X is a little bit expensive because of licensing fees, and it also is slower than running it on the real hardware, especially for builds. We found a 30 to 40% slowdown, which we isolated. We've ruled out a lot of things, and we weren't able to rule out the combination of the hypervisor scheduler and the OS X scheduler kind of fighting with each other. Ultimately, we went with bare metal machines. This is our setup here. We found this one cool trick for speeding up our tests, which is one of these little things. These are the fake HDMI monitor, and they cost about $15 on Amazon. If you plug them into a Mac Mini, the Mac Mini will use the graphics card, the graphics hardware, to render by default when it's headless rather than using software rendering, and this actually speeds up the operation of the simulator by about 10%. So we have now these physical machines. We need to bring them up. Luckily, we have Macs in the office, and so IT had had a instance of DeployStudio already running, so we got set up on that. This is a pretty full-featured network boot solution for OS X. We have it install a base image with OS X Yosemite, and then it installs one version of Xcode and a few things that we need to be able to SSH to the machine to start out with. Once we can SSH, we use Ansible to do the remainder of the setup. Ansible, for those of you who don't know, is a fairly lightweight configuration management system. It's agentless, but it performs a similar job to like Chef or Puppet. This is really cool because it allows really easy config changes. It allows us to see what's on a machine and at the same time run the code that says what's on the machine to actually put configuration onto the machine. We have the machine set up to Ansible themselves now right after they image. So it's kind of like a Chef solo setup at this point. We install multiple versions of Xcode, which we're going to talk about in a second. And this stage is also responsible for installing the Swarm plugin. A quick note about the Swarm plugin, if you're doing this operationally, is that the Jenkins remoting component needs to be the same between your slaves and your master. So anytime you upgrade the master and the Jenkins remoting version changes, you need to re-push a new version of Swarm to all your slaves. So OS X setup, it's really important to match versions with Xcode. Xcode does not operate properly and has had far more bugs for us when we're using a back version of OS X. So we're on Yosemite right now. We're probably going to be upgrading to El Capitan just a little while after it comes out, like maybe the first or second point release. We have our Macs set up to never sleep. This is a little bit difficult on OS X because they keep adding new power settings to make the power settings page in the UI a little less confusing. And so now there are so many settings you can set from the command line that it's difficult to just turn off sleeping. So we use the caffeinate command. We set up a thing called a power assert actually on the Swarm process that's connecting it to Jenkins. As long as that process is running, the machine will not sleep. We turn off software updates, we turn off Spotlight, we turn off Bonjour, we turn off passworded SSH and VNC. This is mostly so that we can get some level of wall around the machine of anyone SSHing in, because hey, my build didn't work, I wonder if I can SSH into this machine. And also to make sure that nothing is changing while we're running a build. As far as Xcode setup, Xcode doesn't like to run from straight command line without having a GUI context. So there are a lot of Stack Overflow posts out there that say something to the effect of, hey, I was setting up Xcode and I got this thing running and every time I SSH into the machine, it doesn't work. But if I go just log onto the machine and use terminal.app, the command works fine. And this is one of the main reasons why. So we actually do automatic login of our build user, and we launch Swarm as a launch agent after that user logs in. So when Swarm pops up, and when the slave jar starts running, it already has access to a running GUI context, and then any process that it starts from Jenkins also has access to that same GUI context. There's another important thing that is necessary for Xcodebuild and the simulator to run side by side this way, which is the TCC database. The TCC database is how Xcode controls access to the accessibility API between processes. So there's a little gist here that will show you how to add launchd into the TCC database. It requires a reboot, so it has to kind of be done earlier in the imaging process. Once you do that, that means that your Swarm, your slave jar, anything that got started as a launch agent has its parentage to launchd, so it will gain that accessibility access, and that'll mean that Xcodebuild can use the accessibility API in the operating system to talk to the simulator, click on things, move stuff around. This is another source of those strange Stack Overflow things where it's like, yeah, and terminal.app works fine. DevTools security is another thing that you need to run. It's fairly well documented, but it's a thing that you forget a lot if you're setting these up manually. So I told you we run multiple Xcodes that we install during the Ansible run. Xcode has a first startup install, which you can trigger from the command line, but it's inherently a GUI process. And this doesn't record very well. We actually record entire installs of Xcode with Composer, and the first startup install, even if we click through it, it doesn't work very well. The reason we switched to recording installs with Composer is because the only way to currently install the iOS SDK in the newest versions of Xcode is actually to do it from the Xcode Preferences pane by clicking on stuff. So we kind of bit the bullet. We were downloading Xcode packages and installing them that way, and now we just make our own packages. So we make one package that's Xcode itself and the command line tools, and then we stop the recording and then make another package that's just after you've started Xcode, what does clicking download all the iOS SDKs do? And then we pull those down. We do side-by-side installs of Xcode, which we put in specially named directories to keep them separate from each other. And then we use Xcode select to switch between them. iOS Builder handles which version of Xcode you're actually going to get for your build so that you can configure it. There's a little more detail on the build slaves on this blog post up on the Squares Engineering blog, The Corner. And there's more coming soon about how we're doing multiple Xcodes because we're actively rolling that out now, so the kinks aren't quite finished being worked out yet. So now we're going to chat a little bit about code signing. Code signing is really confusing. The error messages are super unclear, and it's also a thing that Apple changes a lot whenever they release new hardware. And it's often the source of consternation because your app really needs it to run, and there's kind of no way to get around that. So there are two main things you need to be aware of when you're talking about iOS code signing. The first one's a provisioning profile, and the second one's a signing identity. They're very distinct. People often mess this up when they're talking about it. Signing identities actually have a private key and a public key. Public key is a certificate. The private key actually represents your trust relationship with Apple. So it's important to keep that secret. If you have a large organization, you handle money like Square does, it's important to keep that in a small number of people's hands. The provisioning profiles are just signed messages from Apple to all of its devices. So they're essentially public. Anybody who's ever downloaded your app can see them. So it's not a big deal. There's no access control that you really need on them. Provisioning profiles, like I was saying, they're a message from Apple to iPhone. They are a little bit difficult to open with a text editor, but they basically say, hey, this particular set of devices can run a particular app, and they can run those apps and give it particular permissions, so long as a particular certificate signed the code. And they're actually really nice to you. They take the entire certificate in a binary base64 encoded format, and they just shove it right into the Mobileprovision profile, so there's absolutely no ambiguity as to which certificate they're talking about. These are a little bit difficult to read in a text editor, but you can pop them open with the OS X security command. There are plist that's in CMS format. There's a decrypt option. The signing identities are just X509 certs. They're in DER format. It's all standard. You can look at it with OpenSSL or anything else that can normally read X509 certs. There's a library that a Square engineer put out called Pliny that's written in Ruby that can give you programmatic access to all this. And we actually use this to parse the provisioning profiles and look at the setup that the developer is giving us for a particular build and give useful errors before we even try to create a build. And this has reduced the amount of support we've had to do on code signing. So a little bit about how to make Xcode do the right code signing that you expect. Xcode is very helpy. It has this wonderful fix issue button that it displays to developers. Fix issue will go and just log into developer.apple.com and look at whatever build the developer is trying to run, and we'll just issue whatever cryptographic stuff is required to make that build succeed. This can be a little bit confusing if you're sharing this with a whole bunch of developers and you have certificates or Mobileprovision profiles that represent apps that are actually out there in the wild that you care about. So we ask people not to press this button, and the command line tools actually contain some of this logic, so we actually restrict them. We don't give the CI machines any developer.apple.com access, and we keep only the provisioning profiles that your build needs in the location that it uses for provisioning profiles. Apple Watch apps are, again, a little bit different. There's actually 3 mobile provision profiles, one for the iOS app, one for the WatchKit app, one for the WatchKit extension. And as far as I know, they all have to be on the same signing identity. I've never tried it another way, so I'd be interested to hear if anyone has a reason to do that or what happens. We tell people not to do that. So I mentioned that the private key really needed some level of protection. We use these things called YubiKey Neos. We actually use them for production credentials at Square. They're the second factor for production access. And they have a new feature where they can actually be used to hold a code signing cert on OS X. And they act as an HSM in that they give access to the private key through the keychain APIs, but they do not allow the private key to ever be exported. So if you're using these for signing, the private key never touches the hard drive. Even if someone has access to the signing environment, they cannot steal the key and use it in their own environment. And you can actually create these on device. So the private key could never leave the physical device. You could never have access to it. Or you can import your existing keys and certs if you have some. OpenSC is the piece of software you need. It's up on GitHub. And there's a couple of links on how to do it. This is the Yubico tool that actually allows you to set up certs and keys on the device. And this is a tutorial specific to OS X code signing. It works just as well for iOS. So that's it for code signing. And now I'm going to give you a quick run through of how we find bugs in our build system. So as I mentioned, iOS has a very fast-moving ecosystem, and this means that stuff breaks just because we're upgrading, because we're trying to keep on the newest version of things. And the most frustrating type of error that you can have here is the error that only happens sometimes. And it's frustrating because it's really difficult to reproduce, and it also is impactful. Dozens of developers mean that you have hundreds of builds happening every day. And so the 1 in 100 failure hits somebody every day. If you have a 5% failure, that's a whole bunch of people who are just randomly going to be blocked on their build. And since people usually merge their code when they get a green build, if they introduce one of those errors at maybe 1 or 2%, then they merge their code, and then that adds to the number of errors that are there on master. So these just kind of, in most systems, these actually accumulate on master. So our solution to this is to find a build that passes and run it at night a whole bunch. We already have that physical infrastructure, so we have a whole bunch of build slaves that are sitting idle at night. Nobody's running any builds on them. So we figure out how green is this thing that came up green originally. So these are all Jenkins results from the same Git SHA, and this one didn't work quite right. So we actually take all of these every night and count. We run like 200 or 300 of them per night, and then a few of them fail. And we do some statistical analysis to try to figure out where we want to put our investigative resources. So we model these builds as extremely unfair coins. The way you do this is the binomial distribution. It's important that we have a confidence interval for how well we know what statistical claims we're actually going to make about a build. Because we may have only run it like 300 times. And so something that happens 1% of the time is going to happen 3 times. But maybe it's actually a 2% bug, and you just had a really lucky night where it only happened 1% of the time. So it's important to be able to cage that in. There are a lot of ways to find confidence intervals on binomial distributions. Most of them don't work at the extremes of the distribution. The Wilson score, which we use, does. You can look up both of those on Wikipedia. It'll give you a whole bunch of formulas. So this is a graph of one of the analyses that we do. So this is an example where we had 300 builds in a night, and 2 of them failed. So that blue spike here, which I hope you can see in the back, is at 0.66%, which is the measured probability. We also have this blue curve, which is the probability distribution, given that this is a binomial process. And you can see it's a lot more spread out on the high end than it is on the low end. And that's also reflected in these confidence interval bands. So the purple, green, and yellow bands are respectively 50%, 80%, and 90% confidence. So we can say with a 50% confidence that this failure, given that we've only run 300 builds, is somewhere between like 0.6% and maybe like 1.3%. So then what we do is we can run this on a particular night. We can get a number that says, hey, for the last couple weeks, we've had 99.5% stability. We've had 98, 97% stability. We can also do the same analysis on a particular type of failure. So we can take all the failures that happen. There may be 10 different ways that the build will fail when you do this over and over again, and do one of these analyses for every single type of failure. And that lets us allocate investigative resources. You pick the biggest one. It's slightly more complicated than that, though, because usually we have a small sample size. So here's that same example we had before. We're going to assume that these two failures are the same type of failure, and we're looking at 300 builds total that have run. And this is a few days later. We've had a lot more builds run, but we've had this type of failure happen 6 times. So what happens with these graphs is you can see all the confidence intervals and the probability down here have all narrowed significantly. Up here, we weren't quite sure. We were 50% sure it was between, somewhere around 1%. Here, we're much more sure that it's closer to 0.66%. We're looking at between like 0.6 and 0.95%. So what we actually do is we won't file a bug in this case. And the reason we won't file a bug is because this 50% confidence interval is too wide. It's wider than the measured value is from 0, and this is our signal that we don't have enough data yet. In this case, we would file a bug, we would write 0.66% on the bug, and we would say, hey, this is eating our 99.5% SLA. It's eating all of it, just this one bug, and this needs to get worked on right now. This has meant that we found Xcode bugs, we've found flaky tests, we've reduced the failure rate. We're holding at about 0.5% right now. There's a little bit more detail on the technique and some links to some example spreadsheets that can generate the graphs that I was looking at and have some of the formulas at this blog post on Square's engineering blog. This has overall been really successful, and it's changed a lot of the ways that we relate to developers, because now we're letting them know that they've written a flaky test or they've written a race condition into the app. And so we're actually able to find situations that they wouldn't find, give constructive feedback on how to improve testing, and just it acts as a way to start that conversation with developers, which is really nice. So a year later, we're now running 3 times as many tests on every single pull request, and on master every time someone lands a pull request. We're keeping a 99.5% SLA on our register build. We've gotten a lot of the developer requests to self-service by having there be a proper config language. And we're now able to actually grow the cluster with developer hiring because we've automated a lot of the steps that involve bringing up machines. So it's a fairly low-touch process. So when we find out that the cluster is getting overburdened, it's easy to throw some more machines at the problem, literally. And we're also mostly keeping up with the latest Apple hardware. 7.0 isn't quite available on our build system yet, but we're hoping to have it ready for when Apple makes it generally available. So that's about it. That's all I've got. I'd like to thank our sponsors who made all of this possible. and also the folks at CloudBees, everyone who spoke and attended. Thanks, everybody.